designing of which we will soon begin the construction. We are a group of 22 students from 3 different schools, and we are divided in 4 development areas: hull and structure, fire and control, power unit, and system and electronics.
And this is our boat. The key point of the boat is the integration of fuel cell, hydrogen powered, and the use of hydrofoils. The fuel cell have a 13.5 kilowatts on board and 1.78 kilograms of hydrogen. The hydrofoil system have a big configuration and an electronic flight control. All these things are attached on a hull with 7.3 meters long and made of carbon fiber. The scattering of all these things is accomplished by the ISO standards. As an incoming team, we have to develop different areas of our boat. We are performing different aspects, pushing the CFD and the FEM analysis in order to validate all the design. And here we are to explain different critical aspects of the design that my colleague is going to talk about.
So as for hydrogen implementation, one of our main goals was mainly 2, was reliability and safety. Those were our priorities due to the nature of a high performance and a kind of critical application. So in this direction, we chose a hydrogen fuel cell and a tank, which are commercially available, which are certified by their respective suppliers. And even the fuel cell is out of the box ready for marine applications, so even refrigeration with seawater and everything. So it's a very reliable, very safe couple of components. And at that point, the main concern is the connection between the 2 of them. So that was our main focus, right? Making the connection between the tank and the fuel cell as safe as both the components individually. To this extent, we designed a compartment to house this connection, whose shape is primarily designed to avoid any possibility of hydrogen pockets forming in case of a leakage. Right? So because of the curved shapes, whenever there might be a leakage of hydrogen, it's never a possibility that a pocket might form, and that's a very important part of all this thing, right? As for the ventilation of the space, we are naturally ventilating it whenever the ship's running faster than 3 knots. The air inlets you can see up there behind the head of the pilot, they help us ventilate the space. And whenever we are dropping below 3 knots, a forced air ventilation system engages, so that we always ensure that the space is readily ventilated. We're also installing 4 different leakage hydrogen sensors attached to hydrogen safety valves, right? So whenever hydrogen concentration goes up above 1%, we are cutting off any hydrogen supply to make sure that there's no risk there. This setup was professionally reviewed by Marcos Ruperez, which is a very important professional in this segment. As for flight control and fall control, we are implementing an electronic system. Some teams are already doing this. The main point or the main development we are doing in this sense is that we're installing 5 ultrasound sensors, and our hope is that we are going to be able to predict any incoming waves and develop an algorithm that will adjust control of the foils to compensate for these incoming waves, which are one of the main problems when it comes to hydrogen sailing and foiling. Hydrogen foiling with waves, right? We have been also making some calculations regarding hull performance, hull drag, and foil performance, and taking into account the power of hydrogen that we are installing on board. We have come to the conclusion that we are going to expect maximum velocities upwards of 25 knots, and that the takeoff of the ship is totally guaranteed. So we are confident in our design and in our choices. Lastly, we would like to warmly thank our sponsors for their trust and their generous donations, and thank you also to the organization for giving us a possibility to be here today and explain our project to everyone. So thank you very much, and if you now have any questions, we would be grateful to answer them. Thank you for your time.
Congratulations.
Thank you very much.
Hi guys, nice presentation.
Thanks.
I was wondering, so you said under 3 knots you force air through the hull, but when your boat is turned off, how do you then prevent a hydrogen bubble?
Yeah, when the speed of the boat is high enough, there's natural ventilation is okay, and whenever we drop below the necessary boat speed, we are engaging like fans or fans mainly to make a forced ventilation of the space, and at all times there's even if the boat is stopped in the docks or whatever, the space will be ventilated good enough so that no hydrogen will accumulate.
So also overnight?
Yes.
And then one other question. Is your fuel cell completely air-cooled or also water-cooled?
No, it's water-cooled. That's part of the marine aspect of it, is that we can cool it directly with seawater. So it has a sort of an internal cool refrigeration liquid, but the external interface is with marine water, and it's prepared for corrosion and all of these aspects.
Thank you.
Thank you.
I have one short follow-up question. Do you
Sure.
then also pump up seawater through the struts, or is it a closed loop?
No, we pump up water and just drop it from the aft. That's it.
Okay, thanks.
Thank you.
Excuse me, I had another question. For the direction of your hydrogen tank, in the competition rules, you're not allowed to point it towards the pilot. Had you thought about that when you considered it? And if you do have a catastrophic leak, what's your plan?
Well, I mean, we are pretty sure we're compliant with open sea rules, and also we were yesterday at a meeting about the open sea regulation for next year, so we are sure we are compliant. At any rate, I mean, these tanks do not explode per se. There could be a leakage, but they don't explode as like the valve going rogue. And our fuel cell is encased in a steel enclosure. So at any rate, if there was any sort of explosive or high velocity incident, the fuel cell would stop any debris from getting to the pilot.
Yeah, I guess that's two important points. First, it is true that we have to have some improvement on the technical rules of the open sea class. Basically, they asked me to have a light eyes on it, and I will do it. That will be a bit modified for the next year. And the second one, it is true that when you have a potential connection to a hydrogen tank, most of the time it's better to turn it the other way. But the most important thing that you just explained, which is true, is that to have the higher pressure valve to go in the upper part of the boat. So I hope that's the case on your tank. Is it correct, or I do not?
Could you repeat the?
You know, you have the heavy temperature, higher evacuation of pressure in your tank. Most of the time, we are requesting to send it in the upper position. So I don't know on your boat what's the direction of this high temperature, let's say, safety valve.
Yeah, it goes up. Yeah.
Okay. Thank you. Do we have other question?
I saw in your design that the hydrofoils on the side are quite far in the back. Is there any special reason for this?
Are quite, sorry, what?
Far in the back, like almost in the middle or even further back.
Well, I don't know what it looks like, but it definitely, the main foils are up 4 of the center of mass, and the aft foil is behind the center of mass. You could make a system where the foils are behind the center of mass work, but it wouldn't be so much efficient in terms of hydrodynamics. So our main foils are behind, 4 of the center of mass. So yeah, I mean as well the center of mass is kind of recessed if you look at like the midpoint of the hull, and that's because we have all of the heavy stuff in the back, right? So the tank and the fuel cells. So.
Oh yeah, okay, fine.
Thank you.
Thank you. Another last question.
Hello, I've seen that you're using Dynamic Cell to control the foils.
Yes, we are.
That's right. Are you using some gears beside? Or directly control with
So reduction or we're planning on any reduction that would be necessary. We're planning on doing it mechanically. So the kind of systems that we're using here, it's a lever that's attached to the servo, and that is attached to a strut that goes down to the flaps, which is where you actually control. So reduction would be through the lever.
No.
We are not planning on gear reduction at this point.
And are you using waterproof Dynamic Cell or?
That's it.
Okay, so expensive. Okay.
A bit.
Okay, thanks.
And so it's a very nice and ambitious project. So could you please share the issue you had up to now? Because if you want to invite some other to design a boat like that, what will be your advice or mistake to avoid?
I mean, everything's an issue here, right? Probably like get your concept pretty clear, make some decisions that make sense at the very start, and don't fear making deep analysis, right? So if you have to take a month off to research hydrofoils or to research any and all aspects of the boat, definitely do it. So I think knowledge is the best tip I could give you. And of course, partnering up with someone who is better than you at anything, right? So we do have some professional partners and consultants, so that's hopeful as well.
And that was the introduction to my last question. And would you be agree to share as much as possible with all the community of the Monaco Energy Boat Challenge, all the results and not the plan that you have done in order to help other team to design their own boat?
We would like to be as open as possible, really. And in fact, I would like to thank all the teams that are present here and that are not, because their reception when we have been talking to them has been super open. They have always been willing to help us in any way they could and give their contact. So we want to give back. And in that sense, any questions that you have, we are down at the C-Lab in the meeting room. So any questions will be answered, and any design tips or things that we found, we will share with you, and we hope that we make this like a sharing and knowledge community in that sense.
Perfect. Thank you so much. Congratulations.
Thank you. Thank you very much.
Could we please now have on stage? Excuse me, I don't have. Southern Solar, please.
You want to click? Hi, so we're Southern Solar. We're from the United States of America, Louisiana in particular, which is highlighted in red. And there's 5 students on our team, 3 advisors, and then we have 2 technicians. So I'm Jordan.
I'm Claire. I'm Lilia. I'm Taylor.
So this is our boat. So we had a lot of inspiration since this is our first year. And first, we just talked with a bunch of people in Louisiana about boats like L3 Harris and Chance Maritime. We also talked with the University of Michigan because they have a solar car challenge that goes on in Australia. And so like we had talked and like traded ideas. And then we also looked at a bunch of previous teams. They're like what they would post online, like their open source, kind of just to get an idea, because we had no idea kind of like where to start. And so the idea that we had for the boat was to have 4 hydrofoils and then have a rear motor for steering, and then to have very slim, flexible, marine-grade solar panels with a very lightweight deck.
So this is our budget, which I think may differ a lot from some of the current teams, being that we were a first-year team. A large portion of our budget went to shipping and travel, being that we came from North America. We hope to reduce this in the future by shipping via boat. Because this was our first year, we had to take as much time as possible to build, so we did ship by plane. We hope in the future to reduce the cost and also the carbon footprint of our shipping. Being now that we have a vessel that we can work on and improve, we think the next time this will greatly reduce our budget and our carbon footprint.
So as previously mentioned, we are a new team. This was part of our senior project for mechanical engineering, and we started in August of 2022, forming the team and slowly designing the boat through the fall. In the beginning of the spring, specifically January, we started the manufacturing process and testing all of our subsystems and making sure that the boat was ready to ship to Monaco.
So next up on the specs, we have 2 propulsion units. They're at the bottom of the mast of our hydrofoils in the back of the boat. So they're 42 volts and the masts are 32 inches long. And then for the battery and controls, we have we made a battery out of cells of 11 cells in series and then 2 strands in parallel for a total of 40.7 volts and 35 amp hours. And then we used an EMU BMS for the battery management system. And then we used VESC motor controllers in order to drive our motors. And then for photovoltaics, we used the Solbian SP series, the marine grade, and we used an MPPT to control the charge.
So the improvements that we made, first for our propulsion, we decided to use linear actuators because we were having some trouble lifting with our hydrofoils. So now we have the actuators that allow us to change the angle of attack. And then for the battery, we were having some issues cooling, so we were incorporating like metal, aluminum plates to help in the heat transfer of it. And then for the actual solar panels themselves, we ran a bunch of tests and like IV curves to see like the amp and the power of them all, so that like we could compare the manufacturing data to our own data.
So we had some performance results with our propulsion system. We were able to individually control using the 2 separate controllers, so we could maximize the RPMs versus controlling both motors off of one controller. Our BMS is able to keep all the cells balanced within a half a volt of each other, as well as monitor the temperature of each individual cell with a thermocouple. And doing the test on the solar modules, we found they were within 5% of the manufacturer's specifications, so they perform as we expect.
Throughout the design and manufacturing process, as a new team, we ran into a lot of problems. Here's some 3D printing problems that we ran into recently, a lot of weather problems. Also, having to test our boat with alligators makes it a little bit hard, but we were able to do it, and we performed a lot of tests, and doing that was able to help us zone in on all the specific problems that we had with our design.
So then the victories, the project was definitely really rewarding as a first-year team. We started from nothing and basically built up from there. So we were able to foil out in the lake, which was our first like super large accomplishment. And then just tuning in the steering and getting the whole deck on and everything, and getting a functioning boat shipped all the way to Monaco was also a big accomplishment.
So we'd like to thank our support, first for our sponsor, First Solar, and especially George Antoon, who's like the CEO. Also just our university, we got to talk a lot with our president, Dean Savoy, and also just First Solar representatives in general.
We also had the support of Dr. Terry Chambers and the Louisiana Solar Energy Lab, which is where we were able to do all of our work. They provided us with a workspace, else we would have had nowhere else to work on the boat, so it was extremely helpful. These are all of our vendors. Max Amps, First Solar, and I believe Ocean Planet are American-based companies, so we tried to source things that were made in America.
I'd like to thank y'all for your attention, and do y'all have any questions?
Congratulations. I'm very, let's say, I really appreciate your presentation, especially for a first year. I guess really congratulations. Do we have some questions?
First of all, it is really impressive as a first-year team. I was wondering, why did you use this strut layout, as it's relatively unique to have 4 struts rather than 3? Just wondering.
So our original plan was to use 3 struts, but it turned out to be a little too complex for our time frame. So we decided to go with 4 because it was easy to modify our deck, since it's an 80-20 deck. It just made it a lot easier on us to go that direction.
One quick other question: how is foiling in the waves?
It was very different, tough. Yeah, it definitely took a while to get used to.
Cool.
So that was a good question. Who was able to foil today? Okay. That's why he has a question. Okay, do we have another question? Yes.
Hi, thank you. As one of the first teams who managed to actually get to Monaco from North America, or even anywhere which is really far from Monaco, what advice could you give to a new team that would like to try to do the same?
I would say don't be afraid to reach out to other teams. I think that if we would have done that, it would have been a little bit easier, and also start early. We started the shipping process like what we thought was pretty early, and it turned out to be very complex, just between the batteries and the passport for the boat itself and everything. So definitely starting early.
And maybe you can also, because if they come to Canada and you want to come back next year, you can have a common transportation in order to divide by 2 the price. Yeah, that might be something to do. Do we have another question? Yes.
Are your rear foils rotate when steering?
Yes, sir. That's how we steer on plates.
Yes, and it is an advantage, or it is more difficult to manage the boat in the waves, as example?
I think that the motors rotating is definitely an advantage. We tried a few different methods. We tried a rudder, and the motors rotating definitely worked better than the rudder. I'm not quite sure about the waves. Taylor's the one who took it out there today.
Yeah, it wasn't bad. It was relatively easy to turn them into waves. Our problems were more on the foil side, but yeah, it was relatively easy to steer in the waves.
Yeah, that's something we do not share in the notice of race, and that there is a shallow water in Monaco.
Yeah.
Okay, thank you so much. Okay, can we please have now on stage Zuni Boot team? I don't know if my pronunciation was good. Zonaboat? It's a E, hein?
Non, mais c'est écrit correctement, j'ai vérifié 3 fois.
Zonaboat, sorry.
Sonnebaut team.
Sona?
Sonnebaut team.
Sonabo team, sorry.
Ah ouais, ouais, c'est ça.
Et ça se prononce? So sorry for my pronunciation. I let you explaining the good, correct pronunciation.
It's said wrong every day. Hello everyone. We are the VHL RS Solarboat team. We have been a team for 16 years, and our hull is currently 9 years old. So we are quite an old team with quite an old boat. Our main sponsors are the 2 schools we belong to. So that's the Van Hal Larenstein and het RS VMBO en MBO. Our team currently exists of 9 students from different biological studies. That's one thing that we are very different in than most teams. We are not a technical school. Our team was founded in a sustainability project for the environment. So with zero technological expertise, they decided we're going to build a solar boat, and here we are today, still going. This is a picture of the team last year. We've been coming to Monaco for many years now, and I think we'll be here for many years to come. So our boat is the Sinistream. As I said earlier, it's 9 years old. The hull is made of balsa wood and
flex fibers.
We chose this material because it's more sustainable than carbon fiber. And yeah, that's the main parts of our boat. So now Rex will tell you something more in the details.
Yes, for the life cycle assessment, we really want to have a sustainable boat hull. So as talked before, we have a flex fiber combined with balsa wood as core. There's also some armored fiber in there because otherwise it wouldn't be strong enough. And our boat is going for a very long time now, so that's also why it's more sustainable. Our solar panels we actually got from a reminder slot. It are Google Loom panels that were reserved, and we could use them, and they were actually as efficient as we... First we planned to make it ourselves, but they were as efficient, and we could... So we chose to use the remainder a lot. We also reused our BMS a few times now, with only switching the cells. So we don't have to buy the whole battery a new every so years. Yes, the rest is, I think, not too important. They get switched when they broke, but not that much. Our main innovation point for next year are the hydrofoils. We also already did some testing, and we are planning to do a V-foil. That's different from the most teams, but we hope to get a more more reliable flight with it. But we're not reliable enough yet to really race with it. These are some test photos that we already did. And we now only have to tune the PID of the N to finish the back foil. That are our main innovations now, and yeah, that are our presentation. Does anyone have any questions?
Thank you. Do we have questions on the stage?
Great presentation, thank you. So surface piercing foils generally have less efficiency, and I can imagine that with solar boats, efficiency is a big factor. How much losses do you predict that the V foil will have compared to non-surface piercing foils?
The foils we're using right now aren't that efficient because they're also indeed surface piercing and also not quite big. We first want to get a more easily reliable foiling boat, and we're planning, if that's going reliable, we want to change it to a more efficient foiling system.
Okay, thank you.
I'm interested in this question because the foil is efficient if you are basically really flying. It is true that a waves piercing foiling it's a bit less efficient at the end of the day, but if you the faster you go, the better it is. But I really invite you not always looking at the top efficiency, but the average efficiency on the foil. You know, always when you are designing something, do not think that you have the best boat. So I can share you my experience in the final of the Little America's Cup. I had the top speed on my boat, but the average speed I was slower than my competitors, and at the end we finished second. So, but I had the top speed compared to the other because I was focused in the best efficiency. So it's something very important to all of you when you will design boat. Please watch out. For sure, you have to look at the higher efficiency, but the average is also very, very important.
What challenges come with being a team that's that old?
I think the biggest challenge for us is finding enough team members because we are not a technical school, so a lot of students in our school don't think they are smart enough or have enough knowledge to join our team, and therefore a lot of students think they cannot join the team, and therefore we are usually with a low number of students, and that makes it that we have a lot of plans that we want to do, but we can't do them because we don't have enough people to do it. So that's the biggest challenge our team has currently.
And maybe for the jury, could you please share us why do you decide to participate in this solar class? Because of the aim about doing a zero-emission boat, because of the technology, because you always love boats and you say, okay, that's an event where I can join with my university. And what's basically the roots of this participation on the school, which is not technical school, in this specific event?
Yes, I can say for me personally, it's the combination of the doing something good for the environment and pursuing good environmental technology. But also, I just really like to build and think of solutions from how can I make this boat faster, how can I innovate. And it isn't that really much in the study, but so I can still do my hobby at the team.
For you?
Yeah, I think mine is quite similar. It's for the finding out more sustainable ways to improve our technologies, and also because I really like the team. It's they're all amazing people, and the other teams are also all amazing. So it's a wonderful community to be in. So that's also a big part for me.
Thank you, and you are really welcome in this community. So, could we please now have on stage Exocet?
So, hi, my name is Francis. So, I'm part of Team Exocet in Polytechnique Montreal. So, we're at our second participation this year. Last year, we were coming from a 100% battery-powered boat, and this year, we're working towards a 100% hydrogen-powered boat. So the biggest problem that we had last year was with the battery itself. So coming from Canada, sending a lithium-ion battery overseas is nearly impossible. So it's cost restrictive and everything. So that's one of the things that really oriented our design this year. So making us think of the place of lithium-ion in the boat design itself. So our design phase was over 10 months. So starting September and ending in June with a production budget of about 130 euros. So starting with a completely new boat, essentially, and a team transportation budget of 24,000 euros.
So for the project itself, we made a transition to a 100% hydrogen-powered boat, as my colleague mentioned. We used 36 liters of hydrogen pressurized at up to 300 bars, even though we didn't manage to find actually a way to pressurize the hydrogen up to that pressure yet. We also use 2.5 kilowatts of fuel cells for a total of 5 kilowatts. And the thing we really like about our system, and we're really proud of it, is that the fuel cell stack, we can actually adapt in real time the amount of hydrogen that we consume depending on the load that we need. So if we need to cruise at 2 kilowatts, we can cruise at 2 kilowatts and consume less hydrogen proportionally to the load that we need. However, we do not need either to sacrifice efficiency. Because of that variation, we can achieve a peak of 32% efficiency on the fuel cell stack and higher than 36% efficiency at the maximum capacity of the load that we can take. We also used a rim drive motor that we changed from last year, which we used when we used Torqeedo propeller, which was a DC propeller, a pod propeller, and as some other team, we opted for a rim-driven propeller, which reduces the creation of vortexes by the new blade configuration, and we can boost the efficiency from 54% to more than 90%. That being said, we also needed a DC-DC converter, and we chose a Bright Loop converter because it gives us up to 97% efficiency, which is quite high, but it's also able to give us room to grow. So if we choose to add a new fuel cell next year, or even later in the future, we can still go higher in power with that fuel cell without having to change the DC-DC converter.
So as you may have seen on the docks, there are a lot of red shirts going around, but we don't have a boat. So our biggest challenge really was with testing hydrogen. So we weren't able to actually test our boat because there were no facilities in our university to do so. So our closest test site is actually 2 hours away in a different university. So that was a big challenge, and we didn't really feel that it was justified to send a boat which wasn't ready for the competition overseas. So for the economic reasons and for the environmental reasons. Another challenge that we had was financing, so finding the money to do the hydrogen transition from zero was very difficult, and shipping delays on nearly every single one of our components, as nearly everything's coming from outside of North America because we don't have much hydrogen expertise either. So we're aiming to complete our boat by the end of the summer and start testing. So the prizes that we want to present ourselves for are for the Eco-Conception Prize. So we're limiting the use of lithium ion on our boat. And for the Innovation Prize, we also did parallel work on a hydrogen production means, which allows to reduce the carbon impact of hydrogen production.
So as my colleague just mentioned, we we talked about the hydrogen systems already. We have a 100% hydrogen powered system. We can vary the power, but we also thought about, yeah, sure, we have 100% powered hydrogen, but what about the hydrogen itself? Is it sustainable? Is it green? And we realized that up to 95% of the market is not green. So we looked for ways to improve that percentage because we find it really, really low. Only 5% could be technically green, even less than that. And so we partnered with an H2 production company in Montreal, the city we come from, and we developed a new mean of producing hydrogen. So basically right now, most of hydrogen is produced in Canada and in Europe. It's produced by a steam methane reformer, which basically breaks the methane molecules. But to achieve that, you need super high temperatures. And the classic way to do that is to burn the methane, and it's really, really bad for the environment. So we have a very green boat that consumes very bad hydrogen. So the new method, what we worked on, is using electric heating with ceramic radiant panels to change that mean of heating, but keeping the same chemical reaction at the core of the process. So we can reuse the older generation reactors and convert the way you heat them with the new generation heating system. And we our computations and the simulations that we did partnered with the industry that we were working with was that we could achieve almost no CO2 liberated in the environment, because you eliminated completely the combustion of the methane, and the only CO2 that you still have in the system, it's in closed system, so you can encapsulate it really easily and just sell it as a pressurized CO2. But the other really interesting factor here is that right now the best way to produce green hydrogen is via electrolysis. But the problem with electrolysis is that at a large scale it consumes way too much hydrogen, so way too much energy. So what we worked on is a way to drop that energy bill by up to 82%.
So for our life cycle assessment, since we're starting from a new boat, so we're restarting everything, and most of our parts are from outside of North America. We have a pretty high carbon footprint, but a lot of it is also attributed to the flight coming here. So just transportation and all contributes to about a third of our CO2 emissions. So although we've been able to reduce our lithium-ion consumption, just transporting the boat here is a huge source of carbon emissions. So thank you for coming to our Tech Talk. Do you have any questions?
Can you elaborate? You had a different type of propulsion, not a conventional propeller. So instead of having a central shaft, you're just totally new. Can you explain why, and also what type of efficiency you hope to obtain with that system?
Well, the first part of the gain in efficiency that we saw was that by having the blades going towards the center, we can reduce by a large factor the creation of vortexes at the tip of the blades themselves, because they basically don't move; they just rotate about a single point. The other factor improving that efficiency was the fact that the motor uses three-phase electric current instead of DC. So that new kind of motors can help us boost the efficiency. Also, because the blade does not rotate around the shaft and instead it rotates towards the inside, we had problems last year with cavitation. So basically when we tried to accelerate, the blade was too close to the water surface, especially in the big waves in Monaco. We had problems when we came here. And it reduces the performance and acceleration a lot. So that new configuration helps us reduce cavitation.
In fact, sorry, I have a question, because you say 90% minimum efficiency. I don't know what's the best restaurant in Monaco, but if this is a real result, I invite you to this best restaurant. So I'm really inviting you, please, to check these numbers. My guess is that's the number coming from the seller of the engine. But did you measure this number into a laboratory, or that was just coming from
No, we didn't measure the result of the motor itself, but the fuel cell results, also, however, are measured. We have the efficiency curve, and we can show them to you later.
Okay.
You are 100% hydrogen propelled, using your fuel cell, of course. Now, a fuel cell cannot go from 100% to 0% immediately, and it cannot really handle large peaks, but your motor and motor controller do, right? How do you handle these peaks?
So since we were on a boat, we considered that we weren't going to, that we'd just go, well, we have about a 5 to 10 second ramp up time. So we considered just that ramp up time in our normal use. And we're kind of absorbing, so we'll start at a lower power and then just ramp up with the hydrogen itself.
Yeah, okay, I get that. And it also then for the peaks, if you, for example, hit a wave, that you probably have heat losses in the fuel cell, I guess. Is that how you solve it?
I'm not sure I understood the last word you said. The last words you said.
Yeah. So what I'm trying to get at is, at a certain point, your motor will always have peaks, like going up, going down. If you hit a wave, for example, your fuel cell will have to also handle these peaks, but it cannot because it cannot ramp up, like you said. Do you just take these losses as they are, or have you also looked at, for example, using supercapacitors, which might be used in a plane if you want to travel?
We had considered supercapacitors. Honestly, we just haven't gotten there yet with our design. So I think we'd want to test it first and then see if it is a problem, and then arrive with supercapacitors if it is necessary.
All right, fair. Good luck with that.
Maybe you can go back on the Tech Talks, some presentations that we highlight a few years ago. We had a team from France. I guess it was a team from Les Arts et Métiers, south of France, that had an energy class without battery. So exactly this design. And they face a bit this one, like the fuel cell was not able, so the boat was a bit not shaking, but having some peak of power, not depending on the, basically it was coming, the regulation of power was coming from the air compressor of the fuel cell. Pierre, I let you. Yeah.
What molecule are you using in your reformer to produce hydrogen?
Methane.
Methane. And is it biomethane or not biomethane, fossil methane?
We don't use biomethane at the moment. We might look into it, but the nice thing about it is that we don't need to burn the methane. So we turn the methane into hydrogen and CO2 and CO that we can compress afterwards.
Maybe you can explain a bit more how it is working, because you were just highlighting, and that will maybe also give me a chance to ask all of you if you will be interested to create your own energy in this class. So if we have to anticipate the evolution of the rules, would you be okay, give me just a vote by putting the hands up or not, to create your own energy? So basically, let's say you have to create your own hydrogen directly on site, or you have to create your own petrol, let's say biopetrol here on site. Would some of you would be okay for that? Not okay? This is something you like, you do not like? Because we are seeking that as a regulation. Yes, SBM, because it's already ready, I know, but the other one, does not look like. Okay, so it's very interesting that you share this, let's say, side project, because it's very interesting.
Thank you.
Now, can you give a bit more details about how it is working? Yeah.
Yes. So basically, the system works like a traditional SMR reactor. So we take methane and a few other molecules that are impurities inside, and we have the same catalyst chemicals in the reaction tubes. But instead of using a second chamber to heat the tubes, with methane combustion, we use radiant panels of ceramic radiant panels that uses electricity, and we produce electricity in Canada, especially French Canada, from hydroelectricity. So we have green electricity that we use to heat up the reaction for the period of the time that the new reaction needs to be done. So it basically works the same way as a traditional SMR reactor, but we change the heating system from a combustion system to an electric one.
Thank you. Do we have other question? I guess it's clear. Thank you so much. Can we please have on stage Antwerpen? Antwerp. Sorry, my pronunciation is a bit difficult for me. The correct pronunciation is?
You Antwerp.
Sorry. You Antwerp.
Hello everyone, I am Seppe. I'm from the University of Antwerp Solar Boat team, and today I will be presenting our tech talk. So as I said, I'm from the University of Antwerp. We're all students of the Department of Industrial Engineering. This is our fourth time in Monaco. Our team exists of 22 students, 5 master students, 11 bachelor students, and then 5 more volunteers. We've grown quite a bit since last year. Last year, we were only with 9 team members. Our main sustainability model is reduce, reuse, and recycle. First thing is reduce. We try to reduce our carbon footprint by using less carbon fiber. This year, we researched 2 different types of fiber to replace our carbon fiber. The first one was flex fiber, which is quite commonly used. And the other one is Filava. It's a fiber which is made of volcanic rock, which has a lower carbon emission than carbon fiber and higher strength than flex fiber. Our second point is reuse. The hull we are using today is a hull that was already used in 2017, but we chose to reuse it because it's more efficient as our last hull, and we thought we have more problems to solve than build a new hull over and over again. Eventually, we try to recycle as much. Belgium was, a few years ago, the best recycling country in Europe. So in our university and in our laboratory, we have different containers for every type of material that needs to be recycled, like oils, plastics, papers, and so forth. Our goals for this year was to grow our team. Last year, we found that we couldn't evolve our boat enough because we were with so few team members. So this year we made a big step. With more than double the team members, we were able to produce more parts, research more items, and do more testing. Then our second point was learning to hydrofoil. We noticed that all the top teams were using hydrofoils, so we wanted to hydrofoil too. Over around 1.5 weeks ago, our boat took flight for the very first time in our last sailing tests. It was successful. Unfortunately, yesterday we broke one of our struts, so we won't be hydrofoiling anymore here in Monaco. Our third point is optimize, optimize. We noticed everything that was made wasn't verified on our boat, so this year we looked at what points are difficult, going difficult, and what points are really inefficient. Now in Monaco, we are noticing that our propeller, for example, is not as good, so that will be the thing for next year that we will try to improve. This year we try to improve the battery and the hydrofoils, for example. So this is our boat. It's, we call it Torpedo Mark II because the first time the hull was used was just torpedo. But what's new on this boat in comparison to the last time it was used? There's a completely new steering system. Last year with our other boat we were here, with our boat Shark, we had a really difficult time steering with our large rudder. So we increased the disc size so we have more leverage to turn the rudder. We made a new cockpit out of flex fiber because our previous cockpit let in a lot of water, and we tried to use environmental friendly material. And we also made a new deck so we could access everything more easily in the boat, which is also made out of flex fiber. Finally, I want to show you our budgets where we spend everything on the boat, so this does not include travel expenses. The main part is composites, like flex fiber, carbon fiber for the struts, for example, then a bit for fasteners, desk supplies, and then a large portion for our hydrofoil system. So the total budget is around 4,000 euros we spent this year on our boats. For our emissions, we calculated that the total boat is around 100,000 kilograms of CO2 equivalent, which is around 21,000 kilometers driven in an average car in Europe. So this is my TED talk. Oh, no, it's good. Our TED talk.
Congratulations. It looks a bit stressed. Feel free, it's okay. Huh? We are in the same family. Huh? So, do we have some question? Do you remember? I do have one. In fact, what was, let's say, I really appreciate about this free recycle, reuse, this wish about, okay, I am participating in something in order to reduce the emission. But did you consider buying some parts to the other competitors? Is it something that's existing in between all of you, that a new team or a team that has a bit less budget than another one can afford parts to, you know, I don't know if you try it or not.
Our battery cells are from the solar car from the University of Leuven in Belgium. So it's from their previous car, we got their cells and we use them still today after almost 3 years.
And to all the community, do you think that might be something useful if we, as the Yacht Club of Monaco, organize a sort of platform where you can exchange parts, maybe to propose to new teams to have access to some of the parts? I am mainly thinking about the engine for the energy class. You have a fantastic engine on the solar class that might be very useful for some of the energy class. Will it be something okay for all of you? Okay. No, I really congratulations for what you have done. For me, it's perfect. Thank you. Now our team from Monaco, can we please have on stage SBM Offshore? They will explain why they want to produce hydrogen on site.
Hi everyone, thanks for having us today with you. We are very glad to be here and to present our team and our company. We are the e-racing team from SBM Offshore, and our company aims to provide marine energies worldwide. Okay, so, sorry. And that's why we are participating to the event. Today it's our 5 participation. The team was based in 3 different locations: Monaco, France, and the Netherlands, counting 7 nationalities, and an increasing amount of women compared to the previous years.
This year, we compete for the Eco-Conception Prize. Less than 5% of worldwide production of hydrogen is green hydrogen, but we are proud this year. Our production of hydrogen with the pontoon represent 100% green hydrogen, so for the full event. We manufactured our homemade cockpit with French flax fibers and bio-based resin. The main challenges for our carbon footprint was to work with the remote location from the Netherlands.
Talking about the carbon footprint, of course, because of the context of the race, most of our impact is coming from the production of the boat. All the components that we have to buy, example of the fuel cells coming from the US, and the electronics and the carbon fibers. But we've tried to reduce that, and of course, we can see from the breakdown that the electronics and the carbon fibers are the most impactful on our carbon footprint. And as mentioned previously, the flex fiber that we have used for the cockpit is even a negative balance on the carbon footprint because it actually absorbs CO2 during the growth, which is a negative impact on our total footprint. So that's where we stand.
Last year, we faced some issues like eco-conception of cockpit, electric reliability, and green impact. Our integrated cockpit was inspired by, for the flex fiber, by the ballast bag on the pontoon and the shape by the bobsleigh monostructure cockpit.
Okay, let's talk about money right now. So we have a total of $176,000 as a total budget from our team. So we separated our budget into 3 main components. The first one is the boat with $123,000 and another $13,000 to the pontoon itself, our hydrogen generator pontoon. And the last but not least, $40,000 is for our traveling and other OPEX costs. As you can see, the biggest chunk of our money goes to fuel cell, which is about $64,000. So with a very good budget management, we are able to do CFD, computational fluid dynamics. So the aim of doing this CFD analysis is to have a good balance in between performance and also efficiency. And with this study, we are able to come up with the design impacts that we have a fully adjustable concepts. So we are able to change our geometrical of the boat, which is from the motor and vessel trim is fully adjustable. And our cockpit location, for example, this year is lower than our previous participation. So the cockpit is lower than the front beam, which makes our COG lower, better stability, and also reduce the drag while we're in the water. And we also can change our engine location and also the propeller water depth.
Unfortunately, so far, we haven't been on the sea because of an electrical issue on our motor drive. We still expect to be competing tomorrow with the spare parts coming in today. Sorry. Thanks. Any questions?
Yes. Do we have some questions?
Hello. Considering the different location and the budgets that you put into transports, how did you achieve so low as 12% of your life of the CO2 emissions? Did you use more greener ways like trains or anything?
Well, first, a limited number of people are coming from Netherlands. Most of the team is from Monaco or France in the close area, so in the department itself. So we have limited the impact, the transportation impact, and 3 people are coming from Sweden in Netherlands. So that's how we managed to do that. But a lot more people worked over there, so that was a shared effort, but during the conception phase.
Okay, thank you.
Yes.
Hi, everybody. Actually, I have 2 questions. One for the team, actually everybody here, and one for the competition and the organizers. You were talking about some bioresins. Are they thermosetting or thermoplastic resins? And if you have thoughts of it in the life cycle assessments.
The resin is epoxy bioresin in 30% of bio-based composant. And what was the rest?
If the resin is thermosetting or thermoplastic?
Thermosetting.
Okay,
yeah.
thank you. have you thought of changing and switching to thermoplastic resins in the life cycle assessments of the composites you have?
In fact, that's a good question, because that's one of the consequences that we saw when we edited the report, that even with the bioresin, we could have improved our carbon footprint by using this kind of setup. But we made the report at the end, not before the design. So.
Yeah, and also the point is to keep as long as possible the cockpit we made for the future years.
Thank you. The other one was for the competition, the organizers. Is there something like a cap budget for the teams for the competition? I haven't written the rules actually, if there's something about it, or there's no budget limit.
No, there is no budget limit, but that's also considering the participation. But as soon as you are a student team, then you receive some grants, basically a sort of payback from the inscription, while when you are, let's say, not a professional team, but a team coming from a company like SBM, then you have to pay. So there is a huge difference price in between enterprise and the student team.
If I may add, we are also voluntary, working on extra hours. It's not work paid. It's only on our duties. So that was also a very good challenge to take, because we are all here out of the work. Some of us have to take some vacation to be here while our colleagues are working. So it was the main challenge to work with different locations on the voluntary scheme when we have time and when we can spend some time on our personal, family, leisure time.
Thank you.
And yeah, could you please explain why you take all this in personal investment after the study to be part of this community?
Because it's a nice place to be, first. We like the challenge. Our company is focused on the energy and on the ocean industrial aspect. So we think we got something to give back to the industry, and we'd like to share with the students. And we are also part of the job forum, so we are here to look for new talents. There are plenty of good reasons to be part of this yacht club challenge, and being at the yacht club is one also good reason.
One question about your powertrain setting. So since it's mainly or purely based on hydrogen, the question is, how do you manage transient and the variable efficiency of the fuel cell depending on the different load? Did you do your own control on the fuel cell, and did you somehow evaluated the effects of, let me say, transient response on one hand and operating point and the impact on the overall efficiency?
I'm not sure I got the full answer. Maybe I will get technical support, but I can already start to say that we have increased our robustness of design with some batteries compared to last year, because we have some issues. So to absorb the current peak, we have made a better and self-designed battery. And now Patrick will answer more on the hydrogen production.
Yeah, thank you. We had a lot of issues last year on that. So this year last year we did not have enough power and for all the peaks of amps. So this year we developed high power batteries to cope with that, and it's 30% on battery, 70% on hydrogen. So we have a good mix and a good balance with DC-DC converters to make sure that we have all the needs we have for the peaks, but still we can run for a long time based on hydrogen.
Thank you.
Can we please now have on stage Cayman Ensta? So if you really want to see Cayman, you have to go to Florida, you have seen.
Hello everyone. I am delighted to introduce Cayman Ensta, the team of Ensta Paris. So we are 50 students, 50 general students, plus 4 technical students, and this is our third participation to this challenge. So first of all, ENSTA Paris was founded in 1741 to train marine engineers, and plenty of our students made the catamaran, which broke the world sailing speed record from 1997 to 2007. So for our innovations, our inspirations, we use the automobile sectors with, for example, the Alfa Romeo. And for the materials, we use the Arkema boat system and the Arkema boat materials. We had 3 main parts in this project: the conception and fundraising, so which was basically between September and January. Then the production part, which was after January to June, and then the challenge, which is obviously now. And we have 3 sponsors, and they helped us raise the 6,000 euros that we used for this boat.
Okay, so now let's talk about the conception and design of the boat. So we're using 2 motors of 3,000 watt power each, a total of 8.8 kilowatt hour battery. Power for the previous point. A 1.5 square meter solar tile, and then we have a 4G telemetry system, so able to send data from the boat and then to the onshore team. We have built recyclable cockpits, and the whole structure is made out of aluminum. So the energy on board is provided by, as I said, 2 solar tiles of 115 watt peak each. And these 2 tiles were provided to us by one of our sponsors, Sunstyle. We then have 2 batteries on board. So the first one of 3.8 kilowatt hour, and then the second one of 5 kilowatt hour, both lithium ion. And the first battery was gifted to us by our second sponsor, Neogi. So concerning the propulsion system, as I said, we have 2 motors, 2 waterproof motors, of 3,000 watts power each. We have a water cooling system going through the motors, and for the propellers we're using 7-inch propellers. And one of the brand new additions of our boat this year is the conception of a cockpit. So we used polystyrene foam to create a mold, so using hand saws and belt sanders, and then we put glass fiber on top of it and used a thermoplastic resin from the Arkema, and this is a biodegradable resin.
Okay, for the telemetry, we used a 4G system, so we used an ESP8266 to communicate with the Arduino IoT Cloud platform. And so with this connection, we are able to see the capture of the sensor that we have on the boat. About the efficiency and the performance of our boat, you could see the different steps of our participation in the Monaco Energy Boat Challenge, and you could easily see that we slightly improved the design of our cockpit. So it's more aerodynamic and a more efficient use of the materials. We also have a new steering system and new propellers that have been partly designed by the technical student that helped us during the project. We also have two batteries, so we need to have a selector to select one battery or the other when the first one is empty. And we also have modular solar tiles, so we are able to dismantle this setup if there is no sun. So about our main innovation, we used thermoplastic resin because it was so it's Helium Arkema resin, one of our sponsors, and it's recyclable, and it's the same process as the classic epoxy resin. So it have a huge potential for the market in the boating industry. And so it allows us to reduce the waste and minimize the use of raw materials. And about eco-design, we recycle most of the material from the previous year because we have a very limited budget. And we also use scrap parts to build the polystyrene mold.
Thanks for listening, and we're pleased to answer any of your questions.
Thank you. Do we have some question?
Hello. Hi. Thanks for your presentation. Just one question I had is I found your resin use quite fascinating. Like, I think you're one of the only teams to use a resin cockpit as the way you have. And I'm curious on the sustainability of that and how you hope to recycle that in the future, because you obviously mentioned it, but just a few more details on like what you want to do to it for the future. Thanks.
All right, thanks for your question. So this is indeed a critical part. So there's different ways to recycle the resin. Oh, no. So first, the part is sent to a recycling facility. So it's first shredded into pieces. And then there's either a mechanical way to recycle it. So the resin is pressed out of the part using 2 heated rollers at, I believe, 165 degrees Celsius. And then you can reuse the fiberglass as the residual resin is, the amount is very low. And you can also use a chemical method, which also works for composites. And so you put the shredded part into a chemical reactor, a heated chemical reactor, and the the constituents are separated, and you can extract the resin, and the left out fiberglass is just remains at the bottom of the reactor, and you can reuse it as a chopped fiberglass resin, fiberglass, sorry.
Okay, thank you. Do we have other question?
Okay, great project, guys. Question, what is the voltage of your battery? Is it 48 volt? And how do you switch to the second battery? Is it a mechanical switch or is it an electronic control switch to avoid peak voltages?
For the moment, it's a mechanical switch, but maybe next year we will be able to improve this method to switch from one battery to the other.
And they're both 51 volt, both of them.
Do we have other question? Jury? I do have one. We see huge evolution in between your 3 participation. Congratulations for that. Could you please explain how was useful to attempt to the tech talks and to speak with the other team, to receive the data from the other in order to improve and take the good decision?
Participating the Energy Boat Challenge is very interesting for our team because we are able to discuss with the other team and get new ideas and be able to have more features in our boat, and mainly for the design, we also get inspiration from the other team to improve the aerodynamic of our boat.
Thank you. And last question. It looked like you were very good in marketing because you are coming with some of sponsors. Was it a choose done by your sponsors, especially the engine, or it was definitely you that took the decision of having 2 times 3 kilowatt engine?
Could you repeat the question?
It was your decision to have 2 times 3 kilowatt engine, or it was because that was a sponsor that you decided to use this engine?
No, the engine were not provided by a sponsor. It was our choice to have two motors because we have seen on the Uniboat team that it was very efficient to have two motors, and they were very fast last year.
In the previous years, we had only 1 motor, and we just reused one of this motor and added a similar one just next to it. So that's why we have 2 identical motors.
Okay. Thank you so much.
Can we please now have on stage Sunflare? Did you win this year also?
Yes.
Yes.
So my name is Gerlof Werkman and I'm the pilot of Sunflare Solar Team. We started as a foundation back in 2014, and since 2016 we are racing with the boat. We participate in the solar class. Today of this year is our 7th participation. After a few problems in the beginnings, we became 4 times first. So I think we're the most, yeah. Yeah, we're the team to be beaten at the moment. Yeah. A little bit more about our boat. We made it really lightweight to be as efficient as possible. Our whole boat is sail ready at around 91 kilos. So we skipped all the essential of not necessary parts to reduce the weight. This way we could make the foils as small as possible. We have a 6 square meter solar panel that produces almost 1500 watt peak energy. And with the 6 kilowatt engine we have in there, combined with the counter-rotating propellers, we can reach up to 53 kilometers per hour. And we are using a mechanical foiling system, and mainly because electrical foiling systems are quite complex and it takes a lot of time. And in Monaco, with these big waves, with a really aggressive mechanical foiling system, we can foil even the big waves. Our budget is up to 15,000 to 20,000 euro per year. It's depending on the sponsors. 4,000 of this budget goes to transporting and races. And we use almost 3,500 euros per year on marketing and all the other stuff. And the rest of the budget is basically for development. And over the time, we have had a budget of almost 40,000 euros. And now I'm going to tell you more about our innovation. It's the Advanced Race Calculation, shortly called ARC. We use it because a stable boat wins by strategy. We have to know exactly what we're going to do, when we're going to do it, and all the decisions we make are data-driven. Yeah, it's not really my part. I'm more a mechanical guy, but yeah, we do all the data collection, and with this we transfer it to the shore, so my team can decide what we are going to do and what we are going to use. And we are trying to improve the race planner over the last 2 years. First, we started with a version 0.1. Basically, it was a 2-second polynomial calculation, and this was only usable when we were still not foiling. When we started foiling, we were getting a lot of complicated parts of errors because it was hard to decide what would be better, because we're still able to use our old drivetrain for a non-foiling race and our drivetrain for when we were foiling. So then we started the reason why it was getting complicated, because there's a point where there's not really a speed where we can foil, and it's not efficient to sail there without foiling. So we have shown in the graphs over here, you can see the non-foiling line of the foils, and the orange line is the hull itself on different speeds. And at some point, it's more efficient for us to start foiling. And in the second graph is basically the watt-hour per kilometer. That you can see there's a really hump where we have to get over, and it's also, because we're foiling mechanically, an unstable area where we want to stay out. So there's not a lot of data in that area because we try to accelerate through there. So then we started with a Python script, but they took a lot of time to calculate, and if you want to do a recalculation, you had to put in a lot of numbers. Second version is running on a Raspberry Pi. It's much faster, and it has a UI interface that everybody can get to with a correct access point, and we can just put in the data that we need, set the length of the race, what type of race we have, the solar input, and then it gives us an estimated speed with the motor consumption and what time it will take to get there. So, for example, here's if we do something with foils, it will take us 1 hour 27 minutes. And if we do it with the non-foiling drivetrain, it will take us 2 hours 9 minutes with the specific speed. During the race, we have a small race energy management platform. It's all the data from the boat that we send to a server, and we can read out through Grafana. And it gives us more information about how to use it, what we're going to do with it. Yeah. And there's a lot of potential for it, because you can use this in different areas. It's to give you an insight of all the energy consumption and what's efficient and what not, and how you can use this in the future. For next year, we're looking, a few years ago we started building our own MPPT, but last year we had a fire in the boat, so we had to replace all the electronics. It happens. The problem is that some of the chips that we use on our MPPT are not available at the moment, so around the end of the year we will get access to these again, so we will start making a new version of our MPPT. On the spare time we're also working on a new battery, but the problem was it's not ready. There are some bugs in there, so yeah, it takes more time to put it in a boat. And a few years ago we already said we were building a new boat, or we are planning on building one. Now it took them some time, but this is what we're going to use. It's a little bit combination between our boat and, for example, Technico, because we want to be a little bit wider for a better foiling system, more stability. That's basically our plan for next year. Do you have any questions?
Thank you and congratulations on the time. Do we have questions? Do you remember? I do have one. In fact, that's the first time, maybe the 5th time soon that you're going to win here in Monaco. So it might be because you are a lot better than the other one, but also maybe because they need to have some of your innovation to share to them. So would you be okay to give a bit more open source calculation innovation to those people, other team, or because I understood that this new foiling system was quite new since 2 years, because before you have some sense, let's say mechanical sensors. That was 2 or 3 years ago, I do not remember.
Yeah, it was slightly different, and then we started to use ones that are in front of the foils, so we can participate in what's coming instead of what's behind the foils. Yeah. That makes it slightly more stable. And also we did some improvements on how I don't know if you can see how it's in here. It's without a photo of the ones. So, but yeah, you can come to us. We will tell you more about the system. There are no big secrets, but it's mostly if you have questions, we will answer it. So feel free to come by to check our boat. If you have questions, we will answer it. So
thank you for that. Sorry.
Thank you. Your strategy and your data collection programs look really slick, so that's nice. Do you also take things like sea state, wave height into account in your strategy? Because I didn't see that right now. And
yeah, we do. Let's see. Just before Monaco, when the presentation was already sent, we did some additional add-ins for these type of things. What we do in Grafana, we also can see our estimated energy consumption based on the curves, and then we can see if the power consumption is, let's say, 120% of what we would expect. That we can convert back into the race calculator, and that can say, oh, then we have to use a slightly different strategy. For today, we were on the water, and then, yeah, they said, okay, you have to sail, let's say, 28 kilometers per hour. But as a pilot, I said, okay, I'm more comfortable and more stable on 30 kilometers per hour. And I can see that the energy consumption overall could be slightly lower because we're not falling back into the water. So that's also something that we communicate and then we try to add in, but not automatically.
Okay, thanks.
Yeah.
Thank you. Other question? It's clear. Thank you so much.
Thank you.
Can we please now have on stage RMT?
Okay. Good evening, ladies and gentlemen. Good evening, the judges and all the participants around here. Okay. Okay. I'm Rico Deputra. I'm from RMG Solar Boot Team, Diponegoro University. Okay, maybe this slide. We're from Indonesia. Indonesia is an archipelagic country which has a vast ocean and the second longest coastline in the world. The existence of Indonesia's geographic positions is in the equator, so Indonesia is actually more accurately as the maritime country, where every territory of Indonesia is 70% water and 30% is land. And for our campus, we're from Diponegoro University. Undip is a university that was formed as a symbol of contributions of the nation's successors to the mandates left by the freedom fighters. And this is our boat. We name it Diponegoro 1.0. Regarding our team, we have 19 members. There are 3 part of it. The first one is managerial, and then technical, and then non-technical. In technical, we have hull design and production, and then mechanical, and then electrical. And then for non-technical, we have competition management, sponsorship and partnership, and lastly, creative media. Regarding the production budget, the total production budget is around, maybe that's a typo, it's $25,000 US, and then for the funds to send the ship is $10,000 US. We do shipping from Indonesia to Monaco, and we send it from 23 May, and it's arrived here at around 29 June. So it's 45 days. And regarding the timeline, we have 2 months for the production phase, 2 months for outfitting, 3 months for finishing and evaluation, and we do optimization in January until May, and we do shipping, like I said, in May and June. And then for the efficiency and propulsion and energy on board, we use the propulsion 6.0 EVO for our engine, and then we use the Longji solar cell. We assemble our own solar panels, and we use the base in forms of wood, so that's even more environmentally friendly. Regarding the efficiency performance, we use analyze, namely Maxiv analysis and MMG model. Maxiv analysis for calculating the resistance of the ship, the solar boots, and then for the MMG models is the analysis that's originally from Japan, and we applied it in our boat. MMG from manufacturing modeling groups, analysis innovation that we use for this boat. We use from the 0 speed until our maximum speed, and then it's turned right until the maximum turns to the right. It's like 35 degrees, 35 degrees, 35 degrees, and it's until the right side. And then after that, we do 35 degrees until the 180 degrees of the maneuvers of the ship. So it's calculating the maneuverability of the ship. And then, yep, this is like the usual solar boot systems. The performance of the onboard energy utilization of the ship has been adjusted to the needs and capacities of our solar boots. The max efficiency use the energy stored and obtained by our solar boots. We prioritize that all the energy stored in the battery is for the propulsion system, where the onboard electrical system, we directly use our main power source, namely power from the solar cell via MPPT output. And we designed the electrical control system to be as flexible as possible, which allows pilot to transfer the powers or power switching between the available energy source on board. And here, guys, Diponegoro 1.0 design. and we have some issues. Actually, there are so many issues. This is our first time in Monaco. I'm sorry, guys. There's so many problems in our boat. The first of all is like it's about the funding collection. We must collecting funding more than maybe local European teams, because we should transport our solar boat from Indonesia to Monaco. And yep. And also, solar boat delivery takes quite a long time, so we don't have enough time to optimize it in terms of timeline. It maybe seems like we have long enough space, but also we need to adjust with our partners. Yep. To solve the problem or to mitigate the problems, we're trying to campaign with the media and existing relations. We also contribute to Thrive divided proportions times to work the streets with existing component. And this is our innovation. We're not trying to the innovation features, we go to the problem first. Since the COVID-19 pandemic began, face mask and other personal protective equipment have become essential for healthcare. Disposable masks have been in especially high demands to help to prevent the spread SARS-CoV-2, the virus that causes COVID-19. All those masks carry both the financial and environmental cost, and the COVID-19 pandemic is estimated to generate 7,200 tons of medical waste every day, much of which disposable masks. And even the pandemic slowed down in some parts of the world, healthcare workers are expected to continue wearing masks over the times. And yeah, we're free now, but the impact is not free. And yeah, so there needs to be innovation to mitigate these problems. So it's not only like additional innovation, but it's important innovation that we should do on these kinds of competition to contribute to that things. And how we do that, the first one, we collected from the students and residents at Diponegoro University. We held collection in 2 weeks with 50 students or residents. We do routine COVID testing for our responding, and then we collect them. We quarantine masks for 10 days, the below picture, and then we soak it with disinfectant and we wash it. After we dried, and then we put it in solar boat. No, we sealed it first, and then we put it in solar boat. Next. And then these are analysis toward the innovation. We do 3 various of experiment. The first one is to laminate 2 carbon fiber in 1 mask, and then laminate 1 carbon fiber to mask, and then laminate 3 carbon fiber. We carry out the impact test to determine the impact strength of the test object and the material we use. As a result, it turns out that the most effective ways is to use 2 carbon fibers and 1 layers of mask. We're surprised that the strength is a little stronger than 3 layers of carbons. And yep. And then for eco-conception price, there's 2. There's life cycle analysis assessment and then eco design. We use Marinsif 260 LCA tools. We recycle all the material we use for boat. We try it, and we strive for it. How we do the before production, during the production, and the after production. Before production, previously we made a calculation regarding the material requirement that we use. That's not much material will be wasted, and then in the production phases, we separate waste and different types, and which is mixed or not mixed, because it will be different in processing and solvent systems. And for after production, our waste booster recycle itself, and for mixed waste and solid waste we collect for the processing. We have the 3 partners to do this. The first one is the Institute of Technology Bandung, Wastek International for recycling this, and BRIN as the research institute in Indonesia. With regards to electricity we use, we are currently still connected to electricity from the campus. So it's like conventional electricity, but we have communicated with one of our partners, namely Longi loaning from China, so that our next workshop can be used for solar energy. Maybe that's enough for my presentation. Thank you.
Very nice presentation. Do we have some question on the stage? I do have one. When you made so basically a fantastic idea to recycle the mask of the COVID to do some lamination on your boat, but that was missing maybe something during your tests. You measure the load for the ability of the strength, but what was the weight comparison? Because we have to make always a balance in between the two. So basically, what is the weight of your lamination of mask compared to a carbon fibers per square meter, for example? Do we have this number?
We don't do that, but the mask is thinner than the carbon fiber, but it's thin. Yep. So when you say which one more weight, I think we don't calculate that, but estimately it's lighter. But we don't use that as, okay, we separate our boat as two things. The first one in outer hull and in inner hull. We do this application in our outer hull. So this is our first pilot project. And then for next year, maybe full the boat using that. And yeah, thank you for your recommendation to do some weight calculation.
Jury, other question? It's mandatory for you.
No, I just really like the out-of-the-box thinking on the masks. So I think it's a great example, and hope we can bring benefits and also inspires maybe some other teams to think out of the box on that as well.
Thank you.
And maybe also you can share, because I'm not know if you're aware, but in Indonesia, I guess there is more people going at school by boats than by car. There is just few Europeans understood that Indonesia, it's a very big country, the second biggest, I guess, in number of people worldwide. But there is plenty of islands. So basically, having a team doing innovation in boats is very, very, very important for the world, especially because most of the plastics and the trash you can meet in the ocean are coming from this part of the world. So helping this team is tremendous for all of us, especially for them, but also for us. So I guess a big applause and thank you so much for what you are doing.
Thank you.
Thank you. Can we please now have on stage the EPFL from Switzerland?
Thank you. Pas de souci. So, hello everyone. We are Swiss Solar Boat, a student team from EPFL in Switzerland. We are about 60 students from 14 nationalities, and this is our third participation to the MEBC. As you have seen, unfortunately, this year we could not take our boat here in Monaco. This is due to the fact that we wanted to we work on the hybridation of our boats by adding a hydrogen range extender on it. We also worked on the optimization of our flight control units, and all this innovation will allow us to fly for longer distance in the best way possible. So this is the Dahu, our boat. It's inspired from Polynesian boats, so it's a proa. It has a main hull of 7 meters long and a side hull which is smaller with a planing geometry. We have 3 hydrofoils that allow us to foil over the water and fly over the water, and we can find on the rudder an attractive counter-rotating propeller to maximize the efficiency. As we come from the solar class, we also have 6 square meters of solar panels. So let's see how we fly. We wanted to have 1 degree of freedom per foil. Basically, the main foil, the biggest one, allows us to control the altitude on the boat, as it generates about 70% of the total lift. Then we have the rear and the lateral foil that allow us to control, respectively, the pitch and the roll of the boat. But how do this work? We have motors on the top of the struts that give a translational movement to a rod that is then converted into a rotational movement thanks to pivot at the bottom of the struts. And all this can allow us to change all the angles of attacks of our foil. But how do we command these motors? We have attitude sensors all over the boat that give information to our flight control units. The flight control units will then actuate everything in consequence with all these different informations. So this is a small video of boat flying here in Monaco last year. Everything is going well, but then here the boat drops. This means that the motor just saturated in this moment. We needed to avoid that. We wanted to work more on our flight control units, and to do so, we need to go deeper into our abstraction levels to really make sure that our numerical model will fit in the best way the reality. We are now proud to say that our boat can fly in harsh conditions in a total reliable way. This optimized flight control allowed us also to reduce our motor consumption with the lateral actuators consuming less than 42% less than before. These are just some graphs to show you the difference between our controllers following our set points that we set, so in orange, before and after the optimization. This optimized flight control also had another important task. As we are adding a nitrogen range extender on the boat, this means adding about 50 kilos on a boat that was not designed and not thought like this 3 years ago. So this flight control needs to withstand long flights with variable mass balance. The range extender itself has two main objectives. The first one is to triple our current autonomy, so to reach about 30 kilometers range. The other important aspect for us is to gather information and build knowledge for the team on hybrid solar hydrogen boats, as we are working on a new project that will touch the water by 2025-2026. The range extender itself was made out, we needed to create a new platform to fit it in the boat. So we created a platform in composite materials in the continuity of the cockpit, and then also on the side of the main hull. And we'll not go through all the elements that everybody has already presented in the system on a hydrogen system, but basically there's the tanks, fuel cells, DC-DC, like everybody knows, I think, what we are talking about. But yeah, we had an amazing opportunity to really to take this boat and now use it as a test boat for the next challenge that we want to create with the new boat that will touch about the water, hopefully in 2025. So yeah, thank you very much for your attention, and if you have any questions.
Thank you. Do you have some question?
I guess you have batteries on board?
Yeah, exactly.
And with the range extended, do you reduce the batteries or it is the same?
On the current boat for the range extender, we will not change the battery. We will keep the one that we made for the solar class, because like that it's not a new cost, and we will just use it as a buffer battery for the peak loads.
But it could be a goal to have a smaller battery?
Yeah, for the new, for not the actual boat, but for the new project, we'll be sure to really think on how we will create the buffer battery in the best way to just absorb the peak variations.
I do have a question, because it's a pity that you were not able to be here, especially because that was very shallow water. Would you have been comfortable with this type of waves with your boat?
We would have loved to try our boat out here today. I think it was the best test for us. We are on a lake, so it's pretty calm, but we try to always go out when there are some ways to really test the limits of our control. And I think today would have been one of the best test sessions that we could have hoped. So yeah, it's a bit of pity that we are not here today.
And could you give us some example about what will be the idea about your new boat you want to come from? Because you had this presentation this morning that maybe the students want to know a bit more, especially to Delft, what's your ideas for the next year?
Yeah, TU Delft are one of our inspiration. That's why we want to compete with you. And so yeah, we want to create a boat that's going to have a 25 cruise speed with an autonomy of more than 100 kilometers. So basically that's it. I know I will not reveal anything more, just to keep some suspense. But yeah, we are coming for you, TU Delft.
Yeah, I have two short questions. The first one is how much energy can you store in the hydrogen tanks? And the second one is the division between the power produced by the fuel cell and by the solar panels.
Perfect.
So the energy for the boat currently, so the aim is to triple the energy that we have in the battery for the solar class. So for the solar class, it's 1.5 kilowatts. So it means that we have around 3 times this one in the hydrogen system. And for the next one, we're gonna have a mix between the hydrogen small battery as a buffer and also a solar panel on the top. But the solar panel are gonna be with the main aim for stationary application, because in a boat is main of the time in the harbour, in the ports. So we think about producing energy with solar panels on the top of the boats for the next one.
Is it okay? Thank you so much, gentlemen.
Thank you.
And that was a perfect transition, so could you please now have on stage TU Delft?
All right. Hello, everyone. Welcome to this last tech talk of tonight, probably.
No, we are another one after.
Never mind then. My name is Jesper van der Marel.
Now I'm here. I'm Frank Stavelbroek.
And we are 2 of the students from the TU Delft Hydromotion team. We are a team of 23 multidisciplinary students from the Technical University of Delft. And together we took 1 gap year to build a foiling hydrogen-powered boat. And with this boat, we are competing currently in the Monaco Open Sea class as the only student team for the moment, because now we hear, of course, that the Swiss Solar team is also competing in the coming years, and we also invite all of the other teams to try to do the same. We were originated as a solar boat team 17 years ago, and 3 years ago we saw the potential for hydrogen, and that's when we decided to make the switch from solar to hydrogen. So to give a little bit more insight about our team structure, we have a graph here. We have a management which ensures that all of the team is functioning in their optimal way. And then we have 3 engineering departments, and they take care of different aspects of the boat. And then finally, we have the exposure and operations department, and they make sure that we bring our message, which is pursuing the maritime industry towards a greener future. The exposure department brings that to the outside world. So our goal for this year was to win the Monaco Open Sea Class 2023 with a foiling hydrogen-powered boat. And last year we also competed here. We had a well-performing foil-assisted planing boat, and this year we wanted to take it to the next level and make it fully foiling. And as you can see in the picture, and probably also outside of the harbor, I think we did a pretty good job. So in our year, we go through the entire design cycle. With inspiration from alumni and partners, we design, build, test, and race the boat starting from August, and then entering the production phase in December, testing around April, and then now we are racing here, which is the climax of our year. So in December, we had come up with our design, which had the following characteristics. Not the least important, we come up with our name. The name of our boat is Aurora, because she rises above, on top of the water, and Aurora is the goddess of the rising sun. And as I said before, it's hydrogen powered. It has a 40 kilowatt proton exchange membrane fuel cell. It is 23 feet. The hull is made fully out of carbon. And the design characteristics were that the cruise speed is 19 knots, and its top speed is supposed to be around 27 knots. And we have already reached this speed multiple times, also here in the waves in Monaco. So now Frank will tell you a bit more about the production phase and how we compete for the innovation prize.
Thank you, Jesper. As Jesper said, we're doing the fuel design cycle. So we also do all production by ourselves. So we have a production facility at the university where we, for example, make our own PCBs and have completely assembled the boat. Next to that, we also get assistance for partner in production. For example, we produced our hull at an external location, and we also get financial support from partners. Now a bit more about the technical details of our boat. As Jesper mentioned, the boat is propelled by hydrogen. In total, we store 16 kilograms of hydrogen in 2 tanks, which are pressurized at 350 bar. If we would want to store this amount of energy in batteries, we would need 1,800 kilograms of lithium-ion batteries, and our boat is way lighter than that. Next to that, our boat is propelled by a customized propeller, which is designed for the speed and drag of our boat. It's more efficient than the propeller of last year by making it a bit bigger. Next to that, we also focus in general about making our boat more efficient than the boat of last year. First of all, we optimized our hull, so it's more efficient in planing and has a smoother transition to foiling. And next to that, of course, the most important part is focusing on foiling stability. So every system has been optimized to make our boat foil as stably as possible, even in higher waves, so we can always sail very efficiently. Lastly, also, in order to use less power while foiling, we reduced the weight of every component. Now about the prize we want to compete for. We want to compete for the innovation prize because we are the world's first foiling hydrogen-powered monohull boat, which is actually quite hard because we have a very slim boat. But with that, we are also really efficient. So we can sail at 23 knots at 18 kilowatts of fuel cell power. You already saw us sailing today, the endurance race, and with the amount of hydrogen we consumed then, we can sail more than 700 kilometers. So, for example, sail from the Netherlands to London and back, which is a very extensive range for such boat propelled by green energy. Thank you for your attention, and we're now here for questions.
Do we have some question? Do you remember? I do have one because you have made an amazing job first. Congratulations for that. But I'm sure you are aware that having a wider boat, it's easier to have a stable flight. Why are you still focusing on having a boat that narrow and not looking for a wider boat?
Well, one big challenge here, of course, is also the maneuverability challenge. So by having a slimmer boat, it's we can perform better at the maneuverability challenge. I think that's also a reason why we came second yesterday, and also easier to transport. So now we're able to put our boat on a trailer, and it's just wide enough to fit on the roads, and that makes for easier logistics.
And also for the other team, could you please share how you feel the hydrogen on board? Because I guess if you want to have a hydrogen boat and if the other students want to make hydrogen vessels, they need to know how they can refill this hydrogen. Could you please share these tricks that you have?
Yeah, so actually it's not really a trick, it's quite easy. We go to a hydrogen gas station in the Netherlands, and normally they are used just for cars, like the hydrogen powered cars like the Toyota Mirai. And we have like the connection to our tanks. We put the boat on the trailer, and the connection to the tanks is similar to that of a car. So we can just go to a fueling station and fuel there. We are waiting still for the good connection on the water, but that's something that is up and coming and not really implemented yet.
Yeah, but I know that another team tried to do that in another country, like in Switzerland especially, and they were bound to do that in the station. So that's why I guess it's something that you can share, and maybe the country also can share all together. The second question was on your foil. I am happy to see some winglet on foils because I did not have seen that, and that was one of the questions I want to highlight on the design in the previous days. But most of the time, the winglet are in the other way. So could you please explain to us the design and why you decide to use the winglet in this way?
Yes, so indeed for the front foils, the winglets are pointed down. And for the rear foil, it's actually pointed up. We have chosen this because for the front foil, we didn't want any ventilation to occur, which is more likely when you get to the surface of the water. And for the rear foil, it's deeper in the water, so that was not necessary. And we pointed them upwards because in the case the bottom of the water is lower, your winglets won't just break off when you hit the bottom, but then they are pointed upwards for that reason.
Okay, and last question, could you please explain us what will be the next evolution, ideas, plan for the team, for the university, for you?
We proved this year that we have a quite efficient boat. So actually we have a lot of power in boat, a lot of range. So I think we can even improve more on reducing the weight, making the boat even more efficient than we already did. So I think that's where a big part lies.
Okay, and last, but I am obliged for the jury, do you have used some life cycle analysis on your boat?
No, unfortunately, we have not done that.
Thank you. Thank you so much. And now can we have the last team and the last Tech Talks of this year? Can we have on stage Aritra, please? I guess they leave the mic out. You have everything? But just this one. Yes.
Yeah. Good evening, guys. Welcome to the actual last presentation of the night.
This is true.
I am Rakshan Ramesh from Team Aritra. We've reoriented our goals and rebranded ourselves as Project Pravahan this year, and this is a picture of our team, and we've listed our faculty advisors over there. We come from the Indian Institute of Technology, Madras. Our campus is situated in a 2.5 square kilometer national park, next to a national park, and we are home to about 500 species of flora and fauna, so that talks to the sustainability of our sustainable focus of our campus. And our campus is also host to the Center for Innovation, of which our team is a part of, amongst other student teams such as our Formula student team and our Hyperloop team and our Rocketry team and much more. So coming to this team structure, these are our subsystems and the responsibilities of each subsystem. Okay, so this is our 2023 design. We've taken inspiration from the Energy Observer vessel and McLaren Hypercar for the aerodynamics. And speaking about the novelty in our design, we've also tried to include a regenerative electromagnetic suspension that can harness energy from the relative motion between the hulls and the cockpit. And we've had really great results from mathematical modeling, but unfortunately we were not able to try it out as we faced some delays in procurement of our main components. Also, that is why we are not here. We're here without a boat this year. So, okay. And talking to our energy configuration, we've decided to go with a fuel cell battery hybrid this year with a nominal power capacity of 7.5 kilowatt and a peak capacity of 15 kilowatt. And it's a load compensation configuration, so the high frequency loads are handled by the battery and the low frequency loads are handled by the fuel cell. And this system is designed based on our modeling process. So we've designed our battery and fuel cell, and then looking at the response of each of these systems, we've decided to go for a frequency-based controller. And this is our proposed balance of plant design. Talking about the safety and eco-design in our team, we've ensured to include blowout panels and temperature pressure release devices in our tanks. And also, as an alternative for the required non-sparking fans, we've custom designed a belt-driven ventilation pump so that our motor is completely isolated from the ventilation system, so we don't have to worry about the non-sparking nature of the fans. And all our battery and fuel systems are designed according to the SAE standards, specifically outlined in the Formula Student Germany rule book. And moving on to modular design, we have focused on modularity so that we'll be able to reuse or replace or conduct maintenance in a much more easier manner, and it also has helped us improve our timeline in manufacturing. And I'd like to talk a little bit about our 2024 vessel. So we're planning to go for the Open Sea class next year, hopefully. So we've taken inspiration from the Mayflower autonomous ship and the Independence class LCS from the US Navy. Our design here outlined are our dimensions for our vessel. So we have limited our design dimension according to the internal dimensions of a 20-foot container. So that is basically our only limit for the dimension. And one mistake that I see here, our cruising speed is not 30 knots, our top speed is 30 knots. So, okay. And for the hydrofoils, we've gone with a split canard configuration with one hydrofoil at the front and two at the rear, all of them actively controlled using the same mechanisms as other teams. And we have an azimuthal stern propeller for improved maneuverability, and again speaks to the modularity. If we want to replace the propeller or the motor, it's much more easier than having them integrated into the hydrofoil itself. And as outlined, shown here, we have placed the hydrofoils further away, actually away from the hull itself, so that we'll have more roll stability. And that is also one of the reasons why we've kept the hydrogen, I'm sorry, I'm pointing there. We've kept the hydrogen tanks in the side hulls so that it's further away from the passengers, so also as a safety measure. We've gone with a configuration that is actually similar to our 2023 vessel. We've just increased the nominal output to 35 kilowatt and a peak power to 70 kilowatts. So yeah, again, it is similar to other Open Sea class vessels because our design weight is almost close to other vessels. So around 880 kgs are designed, including the passengers. So yeah, our nominal peak power are similar to other teams. And we've made the sizing decisions and the configuration decision based on the load profile that we were able to estimate and the cost analysis and the carbon emission analysis on the manufacturing of these systems. The novelty that we are trying to include in our next year vessel is by implementing autonomy, or trying to do so. So we are also including all these sensors, and we have outlined the placement of these sensors. So as we go on into the future, we are hoping that we can use these sensors to implement a degree of autonomy, such as station keeping or self-docking, waypoint tracking, and stuff like that. And, these are the explanations for why these sensors are placed and their function and their position. And this is a justification for having an automation in an energy efficiency competition. So in multiple case studies done by multiple companies, we can see that there is significant effect in the energy optimization by the implementation of autonomy. I don't think I have enough time here. Okay, so. And we're currently testing out our automation algorithms with a prototype that we made in our university. We're also bringing this prototype to the NIOD, or Autonomous Ship Challenge, that is happening in Norway next month. I think some of the other teams in Monaco Energy Port Challenge are also coming over there, and we hope to meet you guys over there too. Yeah, open to questions.
Very good job. In fact, I was impressed by some of the team, Indian team this year for the first participation. And do we have some question? Et tu Delphes, normal.
I was wondering how much hydrogen you'll be able to carry on your 2024 boat.
Okay, yeah, so we have these two side hulls that are actually, I think each of them will have around 2.25 kilograms of hydrogen. Definitely not enough to run the whole vessel for a week. So we hope that there are refilling stations over here next year.
We will manage that because it's a question for most of the team to be able to refill hydrogen on Monaco. So we will try to be able to do so. Do we have another question? Yes.
Hello. I have a question about the damping system to create energy on your energy class.
Yeah.
Yeah. How much energy did you calculate or did you measure on this amount of energy?
Okay. So for our design, cockpit design was around 300 kgs, and the displacement of the hull is already given. So based on that, and so LIM stands for linear induction motor. So we built a mathematical model for that in MATLAB and generated a wave profile of 1 meter. Okay, I haven't mentioned the time period, but the amplitude is 1 meter over here. So we were able to get a theoretical value of 400 watts. It's not much, but I think it's still energy that could be harvested.
Okay, thank you.
Sorry, just to be sure, did you take into consideration the mass that you're going to add on your boat by having this damping system? And is it worth it if it's only 400 watts?
Maybe it's not worth it right now, but introducing such a system now maybe could turn out worthwhile later. Maybe through continuous development, maybe it could turn out as a betterment in the energy industry later, because we're also working on wave energy projects in our university, so this is just a smaller version of it. So it can also be adapted to wave energy converters. Yeah, I hope that answers your question.
Thank you very much.
Okay.
Do we have another question? In fact, it's strange because if you drive a car without amortism, it's not normal, but on a boat we put foils without any amortism. So that was one of the questions that as when we designed the first, let's say, flying boat on foils, that was one of the ideas, especially to avoid the peak of load. So maybe you can have a look at it, because that's a way about improving the weight of the boat, because then you can avoid all the peak of energy, so you can reduce the weight of the boat because you have less peak of load inside the carbon. And if you can create energy out of it, that will be even better. And maybe one question to come back to you. Did you consider having the engine at your front foil? Or, because I do not understand rightly, you have the two engines on the back, or you will have one engine in front of the three foil for next year?
For next year, we have one foil at the front, two at the rear, and the thrusters are separate from all of this. It's at the stern.
Okay, the thruster is not located towards the foil.
It's not on the foil.
Because that's also a design which I did not see, and I'm really looking forward to see that, having a front foil with the propeller just in front. That's something that I did not see, and I'm really looking forward to see such solution. I really invite you to have a look at it on the design, because everyone thinks that we have to put engine at the back, but in fact your boat will be a lot less stable compared to having something. You can just write with a pen. Try with your finger to push a pen. The pen will always go on the way than the other one. If you tow something, it's always a lot stable. Because we are looking for stability as soon as we fly, it will be a lot easier to tow a boat compared to pushing a boat. But that's something that we do not see, and I'm really looking forward to see that. So I was hoping that you had the engine in front. So that's why I asked the question.
I'll definitely keep that in mind. It was actually one of our first design choices, but yeah, we'll keep that in mind for next year.
Okay. And last, because after we have to go, but when you design such a boat, so could you please go back on your 2024 design? I really invite you maybe to speak with the Swiss team from EPFL, because if you want to have a hull on the side to have a stabilization, you need to be really sure that it does not increase the drag and oblige your boat to turn. That's something that TU Delft avoid by having just one manhole. I guess it will be a lot stable like that, but as soon as your side hull will touch, so really it's very a big challenge to have a hull that is really giving push and not increasing the drag of the boat. And I guess EPFL, they work a lot on that, on their boat, so that's something that you can all together share in order to have the best design as possible.
Okay, yeah, I'll definitely contact them.
Thank you so much.
And also, I'd like to thank Technico Solar Boat for the open source documentation. As a first year team, it was very helpful for us to learn about hydrofoiling. I just want to highlight that it was a very great initiative. Hope we could all do that someday.
It's perfect. You're more than welcome, and congratulations, because definitely your country and this part of the world, they need to increase, and people like you. So a big applaud, and thank you so much for that.
Thank you for your time, guys.
So I guess that's the conclusion for the Tech Talks. Just before you all go, I want to say a big thank you to all of you, because I know that's sort of extra effort to do the Tech Talks, but I hope that the prize that we will share with you tomorrow will compensate all this effort during this year. And before you all move, and I know that hydrogen is a huge potential in the future, but I really invite you to respect the rules that we are implementing. That's why we will have a closer view on the OpenSea class, because it's a shame, but it was some incident in Italy in a school a few months ago with a student and a teacher that has an experience on hydrogen, and I really want to avoid that it happen to in your school and university, and especially the people that will attempt to the energy class challenge. So please, if we have some rules, that's mainly for your safety. So it's not to ban you. I'm really trying to share as much as possible with you, try to invite you to have the most ideas possible and fostering all together. But the safety is the most important. So in the SOCLAR class, energy class, and soon in the OpenSea class, this regulation will be mainly for the safety of you, of the next generation, of the new kids arriving. And when you are designing hydrogen vessel, please consider that it's a lot of energy in a very short, let's say, area, and that can be dangerous. For sure, battery can be also dangerous, but it's something that I really invite you to be really taking care with you, when, especially when you are passing the relay of the new generation. Ask them to be always cautious about this, batteries, hydrogen, because I do not want you to be injured during this Monaco Energy Boat Challenge preparation. Thank you so much for your attention, and looking forward to see you tomorrow on the water and maybe next year for the other one.